Hello everyone, this is the first pre-lecture video of GIS and Urban Informatics course delivered at UNSW, School of Built Environment. In this lecture, we are going to learn about GIS and Urban Informatics definitions and themes and its applications in urban planning and smart cities. Informatics refers to the representation, processing, and communication of information in natural and artificial systems. If you look for urban informatics terms, you will find a list of terms gathered in this slide. And among these terms, you can see that the role of GIS is apparent. There are also other terms for urban informatics, such as smart cities, urban remote sensing, smart transportation, IT, IoT, and big urban data processing and modeling. In this course, we will learn about some of these themes, including GIS and web mapping. Now, what is the definition of GIS? A geographic information system is defined as a multi-component environment that is used to create, manage, visualize, and analyze data and its spatial counterpart. My definition for GIS is the science of location that helps making better decisions based on the knowledge, pattern, and trends that can be extracted from location data. The data for GIS can be collected by sensors, by satellites, but by people. Nowadays, we have apps for data collection that I will explain for you shortly. Usually, we produce maps to communicate our data and our results with stakeholders. Our need for GIS creates GIS jobs such as GIS analyst. In GIS environment, we make various layers of the real-world environment based on the similarity of the objects. For example, we can make an elevation layer based on the elevation information of the terrain, or we can make a layer for man-made objects and another layer for vegetation cover. We can also make transportation layer that includes all the streets, highways, and intersections. All these kinds of information can be stored in different file formats such as raster and vector. We will talk about raster and vector data types later in this course. GIS is a very powerful system. Why? Because we can identify patterns. For example, we can find out in which regions in Sydney we have concentration of higher buildings. GIS-based data mining techniques help us to detect such patterns. We can identify problems. For example, we can find out the new hotspots of bushfire in New South Wales. We can apply hotspot analysis technique or emerging hotspot analysis technique to extract such information. Nowadays, point clouds are also becoming more popular and can be used in GIS systems. What is a point cloud? A point cloud is a set of individual points with X, Y, and Z coordinates, easting, northing, and elevation information that is collected by laser scanners. You can see different types of point clouds based on the type of equipment used for generation of the point clouds. One type of the point clouds demonstrated here is called airborne LiDAR data. The distance between the points in this point cloud data is between 15 to 20 centimeters. We can use this kind of data for 3D change detection and therefore determining 3D urban growth. We can visualize terrain and find areas with higher elevation than a specified threshold. The visualization could be two-dimensional or three-dimensional. GIS can be used as a collaborative environment and facilitates better communication among stakeholders of an urban project. Current GIS-based apps gives us the possibility of changing models or maps on site and send the update to office where our colleagues are there. Therefore, we can better communicate with our colleagues who are working with us on same urban project. Dashboards are platforms for deriving information at a glance. Near real-time visualization is possible using GIS-based dashboards. Johns Hopkins University developed a GIS-based dashboard for near real-time monitoring of COVID cases. GIS also is very powerful for shadow analysis. For new urban developments, we can make 3D models of buildings in GIS and see how a tall building affects the nearby buildings in terms of solar access and daily light. You can find that some of the buildings in low-density urban areas even don't get sunlight during winter. How shadows affect vegetation and open spaces? This is another question that can be answered by 3D GIS analysis. If we have elevation information for each 1 meter by 1 meter of land or 5 meter by 5 meter of land, then we can make a hillshade result like the one demonstrated in this slide. And this helps us better imagine the hilly areas. There are many advantages for using GIS for flood hazard control. For example, we can detect the floodplain. We can identify the areas at higher risk of death threat. We can conduct proximity analysis to classify the affected urban areas by flood hazard from low risk to high risk. As seen in this slide, the areas with higher risks of flood are demonstrated with yellow and red colors. We can even use GIS systems to get warning messages during flood. You can create dashboards that demonstrate the areas with levels of risk to flood, tornado, and etc. And in this course, you will learn how to make a GIS-based dashboard that includes maps, legends, and process data. We can find the best locations for a building, for example, a primary school. Multi-criteria evaluation and overlay techniques in GIS environment help us to make such decisions for the best locations of assets. We can conduct suitability analysis using GIS. For example, we want to know in which urban areas we can build a new primary school. To find best location for a primary school, we need to define our criteria and gather information for those defined criteria, such as land use. Certainly, we cannot consider a primary school next to a hospital. Elevation is also another important layer because we need to avoid making the school in a slant, steep areas. We need to know where recreation sites are so that we can build a school near these sites. We also need to know where other primary schools are. Of course, we do not want to plan for the location of a school near to the previous ones. We need to process all these data sets and overlay them to find the best location for the primary school. Now, what are other technologies for GIS? Nowadays, GIS-based apps are very helpful for fieldworks and collaboration among group members. Cloud-based data analysis in new products such as ArcGIS Pro has increased the pace of analysis. As you may know, big spatial data such as points of interest on Google Maps are being generated nowadays, and for analysis of such big data sets, we need to have appropriate platforms. Cloud-based platforms help to run analysis for millions of points in a few minutes. Indeed, big data can be analyzed these days by far faster than a few years ago. Nowadays, we can see our GIS models in VR environment, and we can add our model to real world by augmented reality techniques. We can see photos of our city analytics augmented reality sandbox here in this photo. Using such technology, we can better understand the concept of contours and topography. GIS-based systems can be developed for early warning during hazards such as flood, bushfire, or storms. Nowadays, integration of BIM GIS is a hot topic, and this technology is advancing by GIS companies such as Esri and also building information companies such as Autodesk. These big tech companies are partnering to better integrate building information models within GIS environment. BIM refers to building information model and is a detailed model of a building. There are different types of apps available nowadays based on GIS. Some of these apps can be used for fieldwork and data collection in the field. There are GIS-based apps for better communication between colleagues in office and in the field. Apps such as Collector, Navigator, and Explorer. Here you can see one example of GIS-based app I produced for one of the projects with a team of researchers at a School of Built Environment and Civil Engineering. The aim was to improve such app for drivers to be able to make plan for parking. This app provides occupancy information on the parking bays. Using such an app, a driver knows which parking bay are vacant and which one is occupied and which one is reserved. If developed, such an app can help to reserve parking bays when we are at home. We even can see how long it takes for us to travel between origin and destination. For example, between a vacant parking and the university. Wow, drones. Have you used drones to take photos? Another application of drones nowadays is for updating maps and scenes. These updated maps can be visualized and assessed in GIS systems. We can use drones to collect elevation data to make digital elevation models or digital surface models. How GIS is used with virtual reality and augmented reality. Please watch these videos in your own time and learn more how VR and AR can be developed based on GIS data for various applications. If you Google smart cities, you will find the definition of a smart city as an urban area that uses different types of electronic Internet of Things or IoT sensors to collect data and then use insights gained from the data to manage assets, resources, and services efficiently. GIS tools and techniques help us to gain insight from the data and make data-driven decisions. Doing so, GIS helps for making cities smarter. For example, we apply hotspot analysis and we will find the location of most problematic streets in terms of the number of accidents. I would recommend you to also watch these videos to know more about the role of GIS in smart cities. Okay, in this video, we learned that GIS techniques can result in better decision making for planners, policymakers, environmental and landscape planners, and so many other disciplines. The location-based data-driven insights gained from GIS analysis assists in making cities smarter. Integration of GIS and trending technologies makes urban planners and many disciplines powerful for multi-criteria evaluation of various alternatives and even a better communication among different stakeholders. This is the end of the pre-lecture video for week 1. Thanks for watching.